school, I think. I remember. It gives me great pleasure to... fire exits and everything, don't forget. And don't forget to order your lunch. Oh, no, it's too late. For those of you who don't know him, this is Achim Vollhardt, who comes from Switzerland. And he's going to do 2 presentations for us this afternoon. The first one is about AMSAT-DL activities generally, which was originally going to be given by the president of AMSAT-DL, Peter Gülzow, who's a very regular attender. So, but Achim has very kindly stepped in because he can read and translate all the German for us. Off you go, Achim. Thank you very much.
Thanks, Jim, for the introduction. Microphone first. Okay. Good afternoon, everybody. I hope I can entertain you for at least 90 minutes because I have 2 talks today. As Jim already said, the first talk was originally to be given by Peter Gülzow, DB2OS, and this has been only the 2nd time in something like 20 years he's not able to come. No, he's not able to come. I am allowed to come and he's not able to come. No, seriously, he apologizes very much and he extends all the greetings from himself on behalf of AMSAT-DL. But he was kind enough to prepare the slides for me, so I don't have to prepare 2 sets of slides. So the first talk will be a little bit more of an introductory talk about the whole SHale-2/Qatar-Oscar-100 project, the history, a bit of a story around, and the second part of the talk, starting at, 2:45, I believe, will be a bit more directed to actually operating the satellite in the narrowband segment. So usually what we have been talking about, especially for the CubeSats, are satellite orbits, which we call low Earth orbit, which are very close to the Earth's surface. These are typically 500, 600, 800 kilometers, we have learned this morning. In the past, what we had for AMSAT-Oscar-13 and AMSAT-Oscar-40 were the so-called highly elliptical orbits, where the apogee was somewhere between 40 and 60,000 kilometers. And due to the very slow movement of the satellite there, this allowed for basically a couple of hours of intercontinental connections between various continents due to this orbit being non-synchronous or geosynchronous to the 24-hour cycle. So the kind of holy grail of amateur radio satellites was always a geostationary orbit, despite of the, let's say, drawback that being geostationary, it would only cover roughly 1/3 to 40% of the Earth's hemisphere. But this is what we would always call the so-called phase 4 in the AMSAT global or historical mission. Phase 3 were the high elliptical orbits, and phase 4 would be the geostationary orbit. And like it was, I think, in 2012, when we first got in contact with the Qatari satellite operator HaleSat, which is just like Eutelsat or Hotbird or Astra. I mean, these companies, they operate the satellites, they sell this business to customers. And as HALE is actually very well known to the astronomers, it's just called differently. It's called Canopus. It's one of the brightest stars in the southern hemisphere. And the story behind this is, and I just read it up, is the star which becomes visible in the night sky of the Middle East as summer turns to autumn. And traditionally, the sighting of HALE brings happiness, as it means that winter's coming and that good weather will soon be with us. So that's a different kind of perspective, obviously. We hope that the arrival of HaleSat will be equally be beneficial for the satellite community. So again, as already said, the first contacts were tied by Peter during an international amateur radio festival in Qatar in 2012, where he gave gave a presentation about AMSAT and the prospects of having high-flying orbital satellites carrying radio transponders. So the Oscar principle, basically. In 2013, the thing got a bit more concrete. We had requests for RFIs, requirements were finalized. We had in 2016 a kickoff meeting with the company which actually built the satellite in Japan, that is Melco, which is Mitsubishi Electronics, basically. And then 2018, the satellite got launched on the SpaceX Falcon 9. And the person you see in the upper right corner is His Excellency Hamad Atiyah, A71AU, which is, of course, not only an amateur radio operator, but he's the chairman of the Qatar Amateur Radio Society. And I think he used to be the Deputy Prime Minister of Qatar. So he, and amongst others, he was key in making all of this happen, right? Because as said earlier, the times where you can just go to somebody and say, please, 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 can we have a hitchhiker ride on your satellite? These are actually over. And also during Arianespace times, you had to know somebody high enough up in the chain of command who is actually who understands your plea and is willing to help you out, right? It's if it were for the money, I mean, amateur radio community couldn't pay for this. So this is actually one of the few pictures we actually have from the satellite during thermal vacuum testing, or just before or after thermal vacuum testing. And obviously not completely assembled yet. I mean, solar panels missing, antennas missing, but steely-eyed viewers can maybe make out a couple of these TWTAs, the big fuel tanks in the middle of the satellite. And this is all based on a very well-known and well-flown Mitsubishi so-called DS2,000 bus. And again, this is not our satellite. This is some generic picture of how a satellite with this DS2,000 platform would look like. The launch mass is somewhere between 3 and 5 tons, so it's not among the heaviest of the satellites which are currently in use. It's, for obvious reasons, very much compatible with many launchers in the business. And as usual in the satellite business, all of this is has a lot of heritage, right? And people are not very keen on flying untested and unproven systems. So all of this is very well known and has quite some flight heritage. So now when 2018 came and things got a bit more intense, obviously we were from AMSAT-UK asking SHailSat and CARS, like, okay, when this is going to launch. And either they would have told us we won't know, or they won't have told us anything. We always had, let's say, the information third quarter 2018, and that's what we also communicated here. And then usually this slips a bit, so it went for fourth quarter, but actually when at least I booked my flights, it was just, I think, 1 day before or after the static test firing of the rocket, right, which is about a week before. So all of this is really on short notice, and even then if you go there, I mean, you know how this works, you can go there and you have a last-minute scrub, and then basically the clock is ticking. I mean, your return flight is going in 3 days, and maybe they make it, maybe not. But actually we arrived, well, I arrived a day early, like on 13th or on 14th, and well, met with a couple of chaps there. So this was kind of the AMSAT tourist group in the Kennedy Space Center. And so here you see Peter, for those who don't know him. That's Noel, G8, GTZ, I think. Per, DC3ZB, and Jen, G4HIZ. Jen, are you here? Nope. She knows the story. That's fine. So rocket launch viewing that way. And obviously, if you do this kind of once in a lifetime experience, you want to make sure that you're at the right spot. And there are a couple of spots, and one is the so-called Banana Creek viewing grandstand, which is here. For those who have ever been, who has ever been to Kennedy Space Center? Excellent. So this is the vertical assembly building, the big one. This is one of this is 39A and 39B. Sorry, this is B? Can't tell. Ah, well, this has to be 39A because you could, well, you could barely make out the SpaceX building, right? So this is because it's located directly on the tracks. So this is the shuttle landing facility where the space shuttle came in for a landing. This is the place where the Saturn V is lying, actually kind of on display, right? And just next to it are the grandstands, which will be erected during the launch day. So there's place for a couple of thousand people. So we went there, and you can see this is basically dead due east, and it's about 5 kilometers, 5.5, 6 kilometers away, which is as close as you can possibly get with public viewing. So as usual, you turn up there in the morning, try to secure your best spots. Thing is that I think in the evening before, in the night, there was a cold front going through, right? And the launch, the weather forecast had something like, I think, a 60% probability of no-go because of like overcast and the clouds are not good and we cannot do this. But yeah, what do? You just go there and hope for the best. And actually, like, it was always a bit windy and the weather was like, okay, it might even rain a bit, right? But like half an hour before launch, when the SpaceX started to fuel, everything just cleared up and it made a really nice scenery. And then off it went. And that is actually my photo. It's good. It's not as good as SpaceX photo. But they were a bit closer. And maybe I can make a short break here. And because one of the sensations during launch is really the sound, right? And there is a video or a YouTube video from a YouTuber called Smart Everyday, Destin. And he sent somebody with a really, let's say, high fidelity sound recorder there. Not for a Falcon 9, but for a Falcon Heavy. So that's a bit of cheating. But still, I mean, I'll just play a minute or two of the sound and I hopefully have this. Yeah, it'll come because it's obviously a bit in a distance. They were about the same distance as we were, and this is really, I mean, if you have headphones, I mean, check out the video on YouTube. Put on your headphones. I mean, it's really a completely different sensation in most of the videos because it's really this crackling sound and it's really low vibration. And I'm not going to show you the end of the video because there you can see also the boosters coming back and landing with a double sonic boom. So that's a treat for you at home. Not talking about the Falcon Heavy.
That
okay,
sound
so
adds so much for me. That is so incredible. Okay, the next part that I absolutely love. So the rocket.
I have to stop you.
It's up and away, right? The two boosters safely separate.
I know. Great YouTube channel. Check it out. So, and after the launch went, and everything went fine, we got the very generous, I mean, launch went off, and then you can switch to another grandstand where they have the big video screen, and there they had the webcast of the live stream, so obviously we were watching there. If everything goes to plan and the satellite would be deployed properly and without any hitches. And then we already had an invitation, a standing invitation for the post-launch party from SpaceX with the customer. and we were generously invited by SALSAT to join this party. However, the let's say the VIPs from SALSAT, they were not watching this from the Banana Creek viewing grandstand. They had a dedicated viewing spot somewhere on the Kennedy Space Center facilities. So they were at the post-launch party relatively quickly. We had to share our buses with a couple of thousand other people, just going first of all from the grandstand back to the parking lot, and then from the parking lot back to Cocoa Beach. So we were about half an hour late, and then there were these 4 chaps coming. Oh, we want to go to the post-launch party. And then we were like in a club, evening club, so 2 or 3 big bumpers. Oh, you're not allowed to go in here. This is a closed party. And then we said, no, we're invited. Yeah, you look like you're invited. No, we're really invited. please go in and check up. But it cleared up very, very rapidly. It was very, very nice from SpaceX and SALSAT to extend this invitation to us. And then on the lower left corner, you can see that there is this the vice president of CARS, Dr. Ahmed Hamad al-Muhammadi, and the general manager, the general secretary of CARS, Saban Musma al-Yassim. Those 2 guys, and here's myself, here's Peter, a couple of other people there, obviously, as well. And there we got things like these mission patches and some other small, nice things for remembering. Okay, so that is the view of SAL-2 at its final orbital position. It's like something like 25.9 degrees east, which is more or less what you see here. And it is located over Africa. So one might ask, why over Africa? Well, its primary purpose is to distribute television channels from Qatar, right, to the Middle East and North America, actually. North Africa, actually. So that's the main, let's say, customer zone. And actually for us, we have a dedicated antenna on the satellite which covers the whole visible surface. And this is quite unusual typically for these kinds of satellites because they usually have spot beams, and we'll come to this in a minute. So this is just a different projection. SAL-2 at 26 east. Here's Doha. And this also basically sets the stage of what countries can actually reach SAL-2 or the amateur radio transponder of SAL-2. So this extends from somewhere central Brazil, just a bit of the coast of Greenland, Iceland, obviously, the whole Europe, Africa, all the way to Thailand, a bit of Indonesia, central China. And yeah, unfortunately, no North America, and unfortunately, no Japan. So the 3D beamwidth of the antennas, of our antennas on the satellite, are something like, you can calculate it, 70 degrees, and this gives you 20 dB of antenna gain, and this is more or less a purely geometric thing, so it's completely unrelated to the frequency. Whatever we have here, be it X-band or S-band, it will always have around 20 dBs of antenna gain. And then you can also start during the design phase, do all sorts of calculations. What you can influence, however, is your antenna gain on the ground. And I will come to this in the second part of the talk later. Just as a general instruction, there are a couple of calculators on the web where you can basically put in your location, and the software will give you the azimuth elevation angles where to point your antenna. So for Bochum, or for most parts of Central Europe, it will be something direction southeast with an elevation of roughly 30 degrees. This is at Doha. This is very much different. There we have an azimuth pointing somewhere basically southwest with an elevation which is slightly higher. The most interesting part in these plots is actually, one should not forget that the LNB in the feed needs to be rotated a bit, just because the satellites are oriented with their solar panels in the north-south, along the north-south axis. And the perceived orientation of the satellite from the ground obviously changed a bit, depending on where you are. And therefore, your LNB is not perfectly straight, but in the case of Bochum, it tilted a bit to one side, and in the case of Doha, it tilted quite considerably to the other side. So that is for Rio and Penang, basically the other extremes of the edge of coverage. So a very generic block diagram, and to be frank, that's as much as we can deliver in terms of block diagram. Everything else is basically covered with the non-disclosure agreement. It basically shows us that we have both transponders, the narrowband and the wideband transponder, running simultaneously. So it's not that we can use either, let's say, operation mode, either wideband or either narrowband transponder. Both transponders are running in parallel through this S-band receiver, as it is called. This is a redundant piece. So actually, if this would fail at some point, there is another one functionally identical where we can switch over. Both the transponders have separate traveling wave tube assemblies, which are going via this, I think OMT is an orthogonal mode transducer, because the narrowband transponder has a vertical polarization, and the wideband transponder has a horizontal polarization. And this is kind of reflected in the frequency plan, which is also available on the AMSAT DL homepage. We have basically, let me see, here the uplink display, which is in S-band, so that's 2400 megahertz. This satellite segment in the S-band is 24 to 2450, and we are using for the narrowband transponder something right at the lower edge between 24.05 and 24.3, and then the wideband transponder is something like 8 megahertz wide, and this one starts at 2401.5 and goes to 2409.5. And this is basically translated without any inversion to X-band. So we are here just below 10.5 megahertz. The reason for this is because at 10.7 the commercial television satellite segment starts. So if we are not too far away from this, we can basically reuse all the components, and everything will maybe not work as optimal, but will work sufficiently good. And here we have really the separation in horizontal polarization for the wideband and vertical polarization for the narrowband transponder. This is mainly because we were kind of fearing that any signal being transmitted here and driven too hard would generate intermodulation, basically sidebands, which would extend to the narrowband transponder area and therefore generating additional noise. And if properly done, such an additional polarization switch gives you another 20 dBs of isolation. So that was rather easy, and as it turned out at the end of the day, it's also easy for the user on ground, just with a voltage switch to switch between the two polarizations. Okay, some more details on the transponders. The narrowband transponder is the one which is planned, or which is designed for low power narrow bandwidth. So there's voice, that's CW, and let's say the digimodes, as we would call it, right? And it's 250 kilohertz wide. And what we would like to see there, I mean, anything which is less than 2.7 kilohertz, basically. One can argue whether we want to test out with 3, but certainly not something like FM, which is using 12 kilohertz, which by modulation is terribly inefficient, and it uses up a lot of space for other users, basically. So SSB, CW, PSK, but also these digimodes, and a lot of people using now different versions of SSTV or digital voice codecs. We'll come to this on the second part of the talk. The transponder itself is relatively simple. It's a so-called non-inverting band pipe transponder. So we have very little filtering on board. We don't have any intelligence on board. We don't have any adaptive notch filters on board. For those who still remember Oscar 40, we had this LILA system, which was basically tracking the signals which were too large and notched them out individually inside the transponder passband. This is not what we will do, or what we can do it with Oscar 100. And we'll come to this in a minute. So the calculation was somehow done that something like 50 simultaneous QSLs would be supported, and the X-band downlink, which we were calculating as a kind of target system, would be something like a 60 centimeter dish in the so-called coverage peak, which would be somewhere in Central Africa. Unfortunately, there are not many users in Central Africa for QO-100, but maybe this will change at some point. 90 centimeters at the edge of coverage, so that is especially when the satellite is low over the horizon, you have a lot more attenuation due to the atmospheric path length, right? And unfortunately, Brazil, Thailand are also regions where we have a lot of rain, so the water attenuation on X-band and on S-band plays quite some role. So 90 centimeters there is something which we would consider as a minimum. Typically, 75, 80 centimeters is what one would need, basically. Downlink, as already said, on the narrowband is vertical. Uplink is right-hand circular polarization. That's the transponder band plan. And again, this is something which is flexible, right? I mean, this is something which we have set up in the beginning, and it holds up to this very day reasonably well. One can think about if let's say CW is not so much utilized and we need a bit more space for the SSB people, we can shift this a bit back and forth. But this is basically a transponder band plan which has been in place since the days of Oscar 13, and it went quite well. So this is basically the same transponder band plan with the numbers. Again, you can see this difference. It is just a plain up conversion, basically, without any inverting. So if you transmit up with USB, it will come down as USB. Guidelines. No playground without guidelines, without rules. Unfortunately, these are necessary. Please, 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 no FM mode. These are really, really terribly inefficient. They very, very frequently trigger LILA, or let's say drive the transponder into saturation. No transmission below the lower CW beacon. That has not only a technical reason, but also just a regulatory reason, because the amateur satellite services, they start at 2400. And if we have something below, then we actually are violating some band plans. And we don't want to do this. I mean, we have heard this before, that AMSAT in general is known to play by the rules, right? And we should keep this respect from all the authorities, that they know that we are kind of trustworthy. Another thing, you're responsible for your own transmission. I will come to this in the second part of the talk. Another thing, again, no transmission above the PSK beat, and this might change in the future. It is a bit more, it is not as strict here, because the band plan extends all the way up to 2450. However, I mean, we have filed for a kind of, let's say, permit for this satellite for a given frequency range, yes, and this IARU satellite advisor would be the first one to kick us if we would say now, oh, let's extend this by a couple of 100 kilohertz. That's not how it works. Uplink, right-hand circular polarization, so we don't have to rotate any feeds, because in the best of all worlds, the rotation is done by the feed itself. There's a small catch. Some people have been trying these cheap Wi-Fi antennas. They look like a barbecue grill, right? And most of these antennas are linear polarized. So you can make up this with a bit more power, 3 dB more power, but that's the difference between a 5 watt and a 10 watt amplifier, or let's say 20 to 40 watt amplifier. So sometimes just putting there a proper antenna is much more efficient. Yes, we have this LILA system, and I believe we will come to this in a minute. Full duplex operation mandatory. Please have a look on your signal. I mean, we will come to this also in the second talk. We have, unfortunately, a lot of people who are driving their amplifiers a bit too far into the compression. You can see this very easy later in the waterfall display. And actually, I have to say, with the advent of SDRs and waterfall displays, it has never been easier to judge or to qualify your signal for spectral purity or quality. Yeah, last but not least, if you hear the transponder noise more than 5 dB about the LNB noise, everything is fine. The large antenna will not subjectively increase the signal over noise. Again, something for the second part of the talk. So, what is this? This is Peter's talk. I have no idea what he wanted to show there. Nah, that's 740.0. That's probably a birdie. That is an empty transponder, which is not to be seen from now on. That's a typical setup from Rolf, DH2VA or ZF. He was actually doing the first, let's say, official QSO with us on the club station in Doha, Alpha 71 Alpha. And this was kind of the inaugural QSO with Saban, Alpha 71 Bravo Papa, and Peter. And you see that this is the trustworthy S-band patch from James Miller, G3 RUH. And I think in the meantime you have actually tested it for, let's say, uplink power capabilities, because originally it was only designed to be a receive patch, so nobody thought about how much power it could handle. But if I recall correctly, you did some testing and up to something like 100 watts, 150. Everything is fine. So how much do you still have?
Patches?
Yeah? 20. 20 patches are still there. Here's the man. But I think this is the last batch, right? Once they're gone, they're gone. So this is something which is really good, and it has been since like Oscar 40 times. Typically, by experience, 2 watts into 60 centimeters for SSB. Completely sufficient. For those who want to have a closer look, please go down at the AMSAT-UK demonstration station. The antennas are there, the equipment is there. It's very easy to set up everything. Again, we will come to the more details in the second part of the talk. Just as an overview, because the wide transponder will be covered by Dave later in the day, we have here 8 megahertz of bandwidth, and also here the downlink specifications are something between 60 and 90 centimeters. That very much depends on the quality of the signal which is transmitted to the bird. But again, I won't go into detail here. So, a bit more to this inauguration day. This actually happened something like 3 months after the launch of SA2 from Cape Canaveral. So we have been invited to Qatar to actually not only be present during inauguration day, but install our equipment there, because the LiDAR system and these beacons you hear on the transponder, they are generated on the ground. They are not generated inside the satellite as it used to be for the Oscar 13 or Oscar 40 satellites. So this is a map of Qatar, and this is, it's not actually very far. I think this is about 1.5 hours drive. Here's Doha, capital city, and when we were first at the satellite control center, we weren't allowed to basically quote the actual location of the satellite control center. Somewhere in the desert. It's not like that we were driven there with like bags on the head, but I think by now things are a little bit more relaxed. If you go to Google Maps and actually go there and type in something like Satellite Control Center SL, somebody pinned it, and it wasn't us, so it's okay. And this, I think it's actually, this antenna here. It's a 2.4 meter antenna, AMSAT SL2, and it's 100% for us. We don't have to share it with anybody. I mean, obviously they have some big antennas to do some more serious stuff there, but just when it deals for our purposes, for sending up this video beacon, for analyzing the transponder, for measuring the transponder, we have our dedicated antenna. We don't have to share it. Yeah, that's another view. That's actually this one here. And the video beacon is monitored basically 24/7, not only by humans, but actually by computers, obviously. in this capacity management center, the CMC of the SALSAT company. So this is, you can imagine, one of these very impressive video screens which they have there, where they have basically the television programs on all the transponders, and which was a nice touch. The central display in the middle, it featured our video beacon during the inauguration, because during the official inauguration, this video loop, and probably most of you have seen it already, this video loop included a speech of His Excellency Alpha 71 Alpha uniform, forgot his name, and basically making an advertorial for ham radio and the communication between the people, and everybody found this very suitable as an inauguration speech for the whole satellite, actually. So this is, for the amateur radio operators, maybe a bit more interesting. That's a picture of the shelter, where, let's say, the real stuff is going on. So on the left side, you see Peter, after everything has been installed. This is basically a front view of the whole rack, which is just for us. So all these things which you're seeing here are basically designed and installed by AMSAT-DL. So we have redundant power supply here. We have the video encoder here from Thomas. This guy here. There's a second version here. Then we have two LiLA systems, and we have a coax box in the middle where we can switch between the two systems, which are kind of hot redundant. So both systems are running in parallel, and with a flick of a button or some remote command, we can switch between the two systems. We also have here the TS2000 from Kenwood. This was actually sponsored by the Kenwood company, and we're very grateful for that. Originally, this was planned to go in a dedicated ham radio shack somewhere at the SALSAT Satellite Control Center. Unfortunately, in February, this wasn't ready yet. So for the time being, it's just standing in the shelter there, which is, of course, not very pleasant if you want to go there with some very important persons, right? Because the shelter is really chilly, and it's very loud because of all the fans and everything. And here on the right side, you see Kumar, also a very central part of the Qatar Amateur Radio Society. I think his call sign is Alpha 71 Golf Mike, and he has been key in basically supplying everything we need, tooling, antennas. I mean, he's organizing everything. So obviously we had some let's say also some small inauguration ceremony at the CARS headquarters. So that's an outside picture of the CARS headquarter building. Obviously you see here a shortwave beam, but also on the roof now we have some very big antennas for the uplink, a 2.4 meter dish. For the downlink, I think it's 120. And here then a picture with all the esteemed members of the Qatar Amateur Radio Society. Well, not all of them obviously, but a small part, like the management level. This is the Bochum site, and everybody knows that we have a 20 meter dish in Bochum, and we thought this is kind of a, let's say, overkill for the satellite, and we want to use it for something else, right? So we said, okay, what else do we have in the garden lying around somewhere? And not joking, we actually had this 3 meter dish just lying around somewhere in Bochum. So we said, why not? So we have a 3 meter dish for the uplink. That's a dedicated septum feed with a VE4MA choke, which has been tailored basically for this F/D of 0.27. For downlink, we are a bit more modest. It's, I think, 2.4 meters instead of 3 meters, but the downlink is not so much power limited. So in theory, we could run something like 300 watts in this one, and which basically means once we are doing any video transmission from Bochum, we can use quite some power backup to keep the power amplifier well within its linear range, so the Bochum signal is actually quite clean. So inauguration day, 14th of February. Not only we had some happy people there in Qatar, also at the outside, it's really I mean, we were really happy at this day, but another reason why we were grinning like this, because it's so bright there, you just cannot open your eyes when somebody's taking a picture of you. This was the famous button of basically switching on the satellite. You can imagine that this was rather a fake button, but that was the reason why Peter also was allowed to press it once then. And a lot of publicity then in Qatar news, and this is a very big thing for the Qatar society. Yes. Yes. Good. So for the ground segment, I've probably said most of it. This LILA, or the pseudo beacon, is generated on the ground. So that's basically something which provides a signal reference. And we'll come to this later. We have this SDR console which can actually lock on this beacon. It is using the same telemetry format as the AMSAT-UK 13, well, AMSAT-UK 40 actually, because this already had the forward error correction. And but if you decode the data, it's not really meaningful because we don't have actually any satellite data. That's just internal data from the LILA system. The LILA system itself is this Leistungslimitanzeige, which is ground-based. It has a siren marker. Just a week ago or so, we lowered the trigger level again a bit to hit the strong stations a bit more frequent. And the internals of the LiDAR look a bit like this. So we have basically a red pitaya there with a couple of converters, some up and down converters for Qatar. These were made from Michael Kuhne because they had a dedicated frequency location. And this is an IQ modem, which allows us to basically generate the signals directly from, let's say, baseband all the way up to S-band or the 700 megahertz directly. So then we have a bit for the wideband transponder, again, which I'm not going into detail because Dave is going to cover this later. I just want to make sure that we want to redefine the name EasySat, right? Everybody in the past was always going, oh, we have to provide something easy for the user. And in former years, this was always meant to be a low-flying FM satellite. I mean, how much easier than this does it get, right? We have a like 20 euro dish. We have a 12 euro LNB, although I know for sure we have bought these LNBs in Germany for something like 3 euros already. We need an SDR stick. Some of you have this already. And then we need something like a power injector. That's a capacitor and an inductor. That's it. And if you team this up with something like an SDR software, you can very easily be QRV on the satellite within maybe half a day. For those who want to have it a bit more, let's say, less computery, we have down converters. There are plenty of down converters on the market. For obvious reasons, I'm only advertising the AMSAT down converter here, which is basically generating the required voltages for the LNB and then putting out 145 megs for the narrowband transponder and 1339 megahertz for a satellite receiver. The down converter will actually undergo, or is currently undergoing, a upgrade. So the Mark II will be available soon. We hope to have it available by the Ham Radio Fair. Unfortunately, we had problems with the Mars oscillator, which forced us to basically stop the production or stop the shipping just before we were able to release it. But this is much more versatile, so you can change the IF frequency to receive at, let's say, not only 2 meters, but also 70 megahertz, 50 megahertz, 28 megahertz. You still have the 20 megahertz reference output for the up converter, and you will have, let's say, a high stability version or not so high, but still very respectable stability version available. Also, as an up converter, we had something from AMSAT. Also, this is the Mark I, which is more or less out of business by now. The Mark II, again, available soon. It will have quite some more oomph. we're talking here about something like 6 to 8 watts, depending on the final choice of substrate material, which would be just sufficient to run this basically barefoot at the antenna. Good. So this is a possible arrangement of antennas, and I'm not going into detail now because I will talk about this later. This is the actual antenna arrangement from Peter, DB2OS. You can't see it here, but this is his shower. So he had problems in the past when basically grabbing at the wrong handle that he would start soaking his antenna with not with rain, but with shower water. But it does work. And it works very well with this well-known G3 RUH antenna with a fitting patch. And yeah, dual band feeds. I will not go into detail now. This is for later. A big thank you to all who made this possible, especially, as Hale said, cars, obviously, but also there have been many, many more partners. Kenwood, Jamsat supported us a lot, AMSAT-UK, obviously, BATC, all the people who are setting up the Goonhilly web SDR. We had some support from Michael Fletcher from AMSAT-OH and Mindtech and SR Systems, who were building up the whole ground station equipment. So, thank you very much.
Achim, thank you very much. I think we're just bang on. No, we're just a couple of minutes late, so we'll hold the questions. Achim's going to be back in quarter of an hour, but there is a small ceremony to do.
Sorry for taking this over. Achim has very kindly agreed to take, on behalf of Peter, the Reg Varney Award that he was awarded at this year's AGM. Unfortunately, he couldn't make it, so we're going to give it to Peter, and Peter will then take it. Sorry, Achim will now take it. So here's the trophy. I'm sorry it's not very big. Very big. You do that and I do that.
Thank you very much.
We've got a certificate as well.
Yeah, very good. Oh, sure,
all right,
sure.
You've got a bit of presentation on your forehead.
If it's only presentation or not salad, I'm quite happy.
Oh, great stuff. So that's the trophy, which unfortunately we will be staying here. Right.
That's a pity on one side. On the other side, I only have hand luggage, so maybe it's better. It's quite pointy.
Wait and see. Wait and see.
Thank you so much.
Back to Jackie, because this is what you need to take to.
Ooh.
This is for Peter, for him to keep. So
excellent.
So it's a little bit heavier. So will the hand luggage manage it?
It's EasyJet. They
good.
don't have any weight.
Great. A fantastic project, and congratulations to everybody involved. Excellent, well done, and thanks for taking this on our behalf. Yeah.
Thank you very much, and yes, on behalf of Peter, again, thank you for this award. I know he appreciates this very much, and he's very, very sorry that he couldn't attend, although it was planned in the beginning that he would attend here and receive this award in person. So I'm probably going to say what he would have said anyways, which is a big, big thank you to all the members of the AMSAT community, not only AMSAT DL, but all the members of the AMSAT community, which have been very, very supportive of the whole project. A big, big thank you to the team members of the AMSAT P4A group, which have been doing at some point weekly meetings via Skype. So, and I hope I'm not going to miss anybody. So that's Thomas, it's Stefan, it's Jens, it's Michael, Peter, obviously, Thilo, Mario, Dave, Noel, Tillman. Okay. And probably somebody will be mad at me now. I apologize. I apologize a lot, and it was not beyond on bad intentions, but it's really a tribute to all of these people who have helped us in these last 6 to 7 years, and it's a great deal of work. And let's hope we will benefit from it for another 15. years. Thank you.
Thank you, Achim. We're going to take a 10-minute break.